Hello friends, welcome back to my YouTube channel. This is part number 14 of my discussion on molecular diffusion through fluids. And in today's video lecture, I will be discussing one numerical example that is based on estimation of diffusion coefficients for gases by using theoretical equations that have been proposed in the literature. So this would be the second numerical example on this topic. The first one I had discussed in part number 13. So let us begin the discussion. To begin with, we will look at the numerical statement. Estimate the diffusivities of the following gas mixtures using Fuller's method. First is acetone air mixture at standard temperature pressure conditions. Second is nitrogen carbon dioxide at 1 standard atmosphere and 25 degrees Celsius. Third is hydrogen chloride air mixture at 200 kilonewton per meter square and 25 degrees Celsius. Fourth one is toluene air mixture at 1 standard atmosphere and 30 degrees Celsius. And fifth one is aniline air mixture at standard temperature pressure conditions. Various atomic volumes are given to us. For carbon it is 16.5, for hydrogen it is 1.98, for oxygen it is 5.48, for nitrogen it is 5.69, and for chlorine it is 19.5. And then for air, the sum of structural volumes is given to us. The sum of structural volumes for air it is 20.1. So basically we have different gas mixtures at different conditions of temperature and pressure, and for all these gas mixtures we are supposed to estimate diffusivities, that is diffusion coefficients, by using Fuller's method or by using the equation that was proposed by Fuller et al. Fuller and his co-workers. So let us solve this. First, let us look at the given data. So we have various gas mixtures at various T and P, various temperature and pressures. Atomic volumes are provided. For carbon it is 16.5, for hydrogen it is 1.98, for oxygen VO it is 5.48, for nitrogen it is 5.69, and for chlorine it is 19.5. So various atomic volumes are provided. Atomic volumes for the elements involved, these are provided to us. So for carbon it is 16.5, for hydrogen it is 1.98, for oxygen it is 5.48, for nitrogen it is 5.69, and for chlorine it is 19.5. The sum of structural volumes for air is given to us. It is directly given to us. It is 20.1. And what is the objective? The objective is to find diffusion coefficients for these gas mixtures at various conditions of temperatures and pressures. So this is the given data. Now let us move ahead and solve the numerical. First of all, we will find the diffusion coefficient for the mixture of acetone vapors and air. So I am going to denote acetone vapors by E and air by B. So we are supposed to find the diffusion coefficient for this mixture at STP conditions. That is, temperature in this case is 0 degrees Celsius, which is 0 plus 273.15. That is 273.15 Kelvin. Then pressure is 1 atmosphere, and we have to use it in atmosphere in the equation that is proposed by Fuller and his co-workers. So we will keep it in atmosphere. Then we need molecular weights of E and B. So let us find those molecular weights. The molecular formula for E, it is C3H6O. E is acetone. So the molecular formula is 6,3H6O. Therefore, molecular weight of A will be Ma is equal to 3 atoms of carbon into atomic weight of carbon plus 6 atoms of hydrogen into atomic weight of hydrogen plus 1 in 1 atom of oxygen into atomic weight of oxygen. So therefore Ma comes out to be 58. So molecular weight of acetone, it is 58. You know that. Then molecular weight of air, molecular weight of B, which in this case is air, it is 29. So that is known to us. Now we need some of structural volume increments. So we will find those. For A, summation of VA will be 3 into atomic volume for carbon. There are 3 atoms of carbon into atomic volume of carbon, plus 6 atoms of hydrogen into atomic volume of hydrogen, plus 1 atom of oxygen into atomic volume of oxygen. So that is, and we know atomic volume of carbon is 16.5. Now atomic volume of hydrogen, it is 1.98. Atomic volume of oxygen, it is 5.48. So therefore summation of VA will be equal to 3 into 16.5 plus 6 into 1.98 plus 1 into 5.48. That gives us summation VA as 66.86. And then for B, summation VB is directly given to us. It is 20.1. Let us move ahead. The applicable equation, that is the equation proposed by Fuller and his co-workers. The equation is DAB is equal to 1 into 10 to the power minus 7 T raised to 1.75 into under root of 1 upon MA plus 1 upon MB divided by P into summation of VA raised to 1 by 3 plus summation of VB raised to 1 by 3 and square of this sum. So MA in this case is 58, MB is 29, summation VA we got it earlier, it is 66.86, summation VB is 20.1, temperature is 273.15 Kelvin, pressure is 1 atmosphere. Now let us use these values in this equation. So therefore DAB will be equal to 1 into 10 to the power minus 7 into 273.15 raised to 1.75 into under root of 1 by 58 plus 1 by 29 divided by 1 into 66.86 raised to 1 by 3 plus 29 raised to 1 by 3 and square of this sum. So therefore DAB will be equal to 1 into 10 to the power minus 7. 273.15 raised to 1.75 is 18352.79 into 1 upon 58 is 0.017, 1 upon 29 is 0.034. So it is square root of 0.017 plus 0.034 divided by 1 into 66.86 raised to 1 by 3 is 4.06, 29 raised to 1 by 3 it is 2.72 and square of this sum. So therefore DAB will be equal to 1 into 10 to the power minus 7 into 18352.79. Sum of this 2 is 0.05. So into under root of 0.05 divided by sum of this 2 is 6.78 and square of that. So that gives us DAB as 9.09 into 10 to the power minus 6 meters square per second. Therefore, the diffusion coefficient of acetone vapors in air at STP conditions, it is 9.09 into 10 to the power minus 6 meters square per second. So in this way, we have got diffusion coefficient for the first gas mixture of acetone vapors and air. Now let us move on to the next gas mixture. Next gas mixture is nitrogen and carbon dioxide. I am going to denote nitrogen by A and carbon dioxide by B, and we are supposed to find the diffusion coefficient at 1 standard atmosphere and 25 degrees Celsius. So T is 25 degrees Celsius, which is 25 plus 273.15, that is 298.15 Kelvin. Pressure is 1 atmosphere. We have to use it in atmosphere, so we are going to keep it in atmosphere. Then molecular weights of A and B. A in this case is nitrogen, so the molecular formula for nitrogen, it is N2. So molecular weight of A will be equal to the molecular weight of A is Ma is equal to 2 atoms of nitrogen into atomic weight of nitrogen. So it is 2 into 14. Therefore Ma is equal to 28. Then molecular weight of carbon dioxide, In this case, B is carbon dioxide. So molecular formula for B is CO2. So molecular weight of B, in this case, it will be Mb is equal to, there is one atom of carbon into atomic weight of carbon plus 2 atoms of oxygen into atomic weight of oxygen. So molecular weight is 44 for carbon dioxide. You know that. Now let us get some structural volume increments for this case. So for A, summation of Va is 2 into atomic volume of nitrogen. There are 2 atoms of nitrogen into atomic volume of nitrogen. Vn is 5.69. It is given to us. Therefore, summation of Va will be equal to 2 into 5.69. That is, summation of Va comes out to be 11.38. Then for B, summation of Vb will be the 1 into atomic volume of carbon, because there is 1 atom of carbon, and 2 into atomic volume of oxygen. There are 2 atoms of oxygen. So if you use the given values, atomic volume of carbon is 16.5, atomic volume of oxygen it is 5.48. Therefore, summation of Vb will be equal to 1 into 16.5 plus 2 into 5.48. That is, summation Vb comes out to be 27.46. Let us move ahead. The applicable equation that is proposed by Fuller et al. The equation is dAb is equal to 1 into 10 to the power minus 7 into t raised to 1.75 into under root of 1 upon ma plus 1 upon mb divided by p into summation of Va raised to 1 by 3 plus summation of Vb raised to 1 by 3 and square of this sum. So Ma in this case is 28, Mb is 44. Summation Va, we got it earlier, 11.38. Summation of Vb, we got it earlier, it is 27.46. Temperature is 298.15 Kelvin. Pressure is 1 atmosphere. Therefore, dAb will be equal to 1 into 10 to the power minus 7 into 298.15 raised to 1.75 into under root of 1 by 28 plus 1 by 44 divided by 1 into 11.38 raised to 1 by 3 plus 27.46 raised to 1 by 3 and square of this sum. So therefore, dAb is 1 into 10 to the power minus 7 into 21392.47, 298.15 raised to 1.75, it is 21392.47 into under root of 1 by 28 is 0.036, 1 by 44 it is 0.023 divided by 1 into 11.38 raised to 1 by 3 is 2.25, 27.46 raised to 1 by 3 it is 3.02 and square of the sum of this two. Therefore, dAb will be equal to 1 into 10 to the power minus 7 into 21392.47 into summation of this 2 is 0.06. So, it is into under root of 0.06. Summation of this 2 is 5.27. So, it is 5.27 square. So, therefore, dAb it comes out to be 1.86 into 10 to the power minus 5 meters square per second. So, for the gas mixture of nitrogen and carbon dioxide at 1 standard atmosphere and 25 degrees Celsius, the diffusion coefficient is 1.86 into 10 to the power minus 5 meters square per second. Okay, now let us go for the next gas mixture. The next gas mixture, hydrogen, chloride and air. Hydrogen chloride, it will be denoted by capital A, and air, it will be denoted by capital B. So we are supposed to get the diffusion coefficient at a pressure of 200 kilonewton per meter square and a temperature of 25 degrees Celsius. So T in this case is 25 degrees Celsius, which is 25 plus 273.15, that is 298.15 Kelvin. Pressure is 200 kilonewton per meter square, but we need it in atmosphere, and we are going to convert it to atmosphere in this way. So 200 kilonewton per meter square, that is 200 into 10 to the power 3 Newton per meter square, and in 1 atmosphere is equal to 1.013 into 10 to the power 5 Newton per meter square. So 200 into 10 to the power 3 Newton per meter square, it will be equal to 200 into 10 to the power 3 divided by 1.013 into 10 to the power 5 atmosphere, that is 1.97 atmosphere. So pressure is 1.97 atmosphere. We need it in atmosphere. That's why we have converted it to atmosphere. Then molecular weights of A and B. The molecular formula for A in this case is HCl. So molecular weight of A, Ma will be equal to 1 into 1 atom of hydrogen into atomic weight of hydrogen, plus 1 atom of chlorine into atomic weight of chlorine. So that gives us Ma as 36.5. Then molecular weight of B in this case is air. So molecular weight of air, that is Mb, is 29. Now let us get sum of structural volume increments. So for A, summation Va is 1 atom of hydrogen into atomic volume of hydrogen, plus 1 atom of chlorine into atomic volume of chlorine. Atomic volume of hydrogen, it is 1.98. Atomic volume of chlorine, it is 19.5. So therefore summation Va is 1 into 1.98 plus 1 into 19.5. That is summation Va is 21.48. And for B, which is air, summation Vp is 20.1. It is directly given to us. Let us move ahead. The applicable equation, Fuller, that is proposed by Fuller and his co-workers. DAB is equal to 1 into 10 to the power minus 7 into T raised to 1.75 into under root of 1 upon Ma plus 1 upon Mb divided by P into summation Va raised to 1 by 3 plus summation Vb raised to 1 by 3 and square of this. Now you must have you must be remembering the equation. We have used it many times. So Ma is 36.5, Mb is 29, summation Va is 21.48. We got it earlier. We got these values. Summation Vb is 20.1. Temperature is 298.15 Kelvin. Pressure is 1.97 atmosphere. So let us use these values. So therefore DAB is equal to 1 into 10 to the power minus 7 into 298.15 raised to 1.75 into under root of 1 by 36.5 plus 1 by 29 divided by 1.97 into 21.48 raised to 1 by 3 plus 20.1 raised to 1 by 3 and square of this sum. So that is DAB is equal to 1 into 10 to the power minus 7. This value of this term is 21392.47. 1 upon 36.5 is 0.027. 1 upon 29 is 0.034 divided by 1.97 into 21.48 raised to 1 by 3 is 2.78. 20.1 raised to 1 by 3 is 2.72 and square of this sum. So DAB will be equal to 1 into 10 to the power minus 7 into 21392.47 into under root of 0.061. Sum of this 2 is 0.061 divided by 1.97 and sum of this 2 is 5.50. So it is 5.50 raised to 2. That gives us DAB as 8.91 into 10 to the power minus 6 meters square per second. So therefore, for the gas mixture of hydrogen chloride and air at a pressure of 200 kilonewton per meter square and a temperature of 25 degrees Celsius, the diffusion coefficient is 8.91 into 10 to the power minus 6 meters square per second. Now let us move on to the next gas mixture. The next gas mixture is toluene and air. Toluene I am going to denote by A and air I am going to denote by capital B. So we are supposed to get the diffusion coefficient at 1 standard atmosphere and 30 degrees Celsius. So T in this case is 30 degrees Celsius, which is 30 plus 273.15, that is 303.15 Kelvin. Pressure is 1 atmosphere. We need it in atmosphere. Molecular weights of A and B. So molecular formula for E is C7H8. Therefore, molecular weight of E will be Ma is equal to 7 atoms of carbon into atomic weight of carbon plus 8 atoms of hydrogen into atomic weight of hydrogen. That gives us Ma as 92. Then molecular weight of B, which is air in this case, Mb is 29. Then sum of structural volume increments. For A, it will be summation Va is equal to 7 atoms of carbon into atomic volume of carbon plus 8 atoms of hydrogen into atomic volume of hydrogen. Atomic volume of carbon is 16.5. Atomic volume of hydrogen, it is 1.98. That gives us summation Va is equal to 7 into 16.5 plus 8 into 1.98. That is summation Va comes out to be 131.34. For B, which is air, summation Vb is directly given to us. It is 20.1. Let us now move ahead. The applicable equation proposed by Fuller and his co-workers, dAb is equal to 1 into 10 to the power minus 7 t raised to 1.75 into under root of 1 upon ma plus 1 upon mb divided by p into summation of Va raised to 1 by 3 plus summation of Vb raised to 1 by 3 square of this. Ma is 92, Mb is 29, summation Va is 131.4, summation Vb is 20.1, temperature is 303.15 Kelvin, pressure is 1 atmosphere. So therefore dAb will be equal to 1 into 10 to the power minus 7 into 303.15 raised to 1.75 into under root of 1.92 plus 1 divided by 92 plus 1 divided by 29 divided by 1 into 131.4 raised to 1 by 3 plus 20.1 raised to 1 by 3 and square of this sum. So therefore dAb is 1 into 10 to the power minus 7 into 22024.23, this term, into under root of 1 by 92 is 0.011, 1 upon 29 is 0.034, divided by 1 into 131.4 raised to 1 by 3 is 5.08, plus 20.1 raised to 1 by 3 is 2.72. So therefore dAb will be equal to 1 into 10 to the power minus 7 into 22024.23 into sum of this is 0.045, so into under root of 0.045 divided by 1 into sum of this 2 is 7.80 and square of that. So dAb comes out to be 7.71 into 10 to the power minus 6 meters square per second. So therefore for the mixture of toluene and air at 1 standard atmosphere and 30 degrees Celsius, the diffusion coefficient is 7.71 into 10 to the power minus 6 meters square per second. Now let us move on to the last gas numerical part. So it is a mixture of aniline and air. Aniline will be denoted by capital E and air it will be denoted by capital B. So we are supposed to get the diffusion coefficient at standard temperature pressure conditions. So temperature is 0 degrees Celsius, that is 0 plus 273.15, that is equal to 273.15 Kelvin. Pressure is 1 atmosphere, we have to use it in atmosphere. Molecular weights of E and B. The molecular formula for E is C6H5NH2. So therefore molecular weight of E, Ma will be equal to 6 into 12, 6 atoms of carbon into atomic weight of carbon, plus in all there are 7 atoms of hydrogen, 5 plus 2. So 7 atoms of hydrogen into atomic weight of hydrogen, and there is 1 atom of nitrogen. So 1 atom of nitrogen, 1 into the atomic weight of nitrogen. So Ma comes out to be 93. The molecular weight of B, which is air, it is 29. So Mb is 29. Now sum of structural volume increments. So for E, it is summation V is equal to 6 into atomic volume of C, because 6 atoms of carbon, plus 5 atoms of hydrogen into atomic volume of hydrogen, plus 1 atom of nitrogen into atomic volume of nitrogen, plus another 2 atoms of hydrogen into atomic volume of hydrogen. So that gives, we know Vc is 16.5, Vh is 1.98, Vn is 5.69. Therefore summation Va will be equal to 6 into 16.5 plus 7 into 1.98 plus 1 into 5.69. That gives us summation Va as 118.55. For B, which is air, summation Vb is 20.1, which is directly given to us. The applicable equation proposed by Fuller and his co-workers. The equation is dAb is equal to 1 into 10 to the power minus 7. Again, many times we have used it. So the equation is 1 into 10 to the power minus 7 t raised to 1.75 into under root of 1 upon ma plus 1 upon mb divided by p into summation Va raised to 1 by 3 plus summation VB raised to 1 by 3 and square of this MA is 93, MB is 29, summation VA is 118.5, summation VB is 20.1, temperature is 273.15 Kelvin, pressure is 1 atmosphere. So DAB will be equal to 1 into 10 to the power minus 7 into 273.15 raised to 1.75 into under root of 1 by 93 plus 1 by 29 divided by 1 into 118.55 raised to 1 by 3 plus 20.1 raised to 1 by 3 square of this. So that is DAB is equal to 1 into 10 to the power minus 7 into 18352.79 this term plus 1 upon 93 is 0.011, 1 upon 29 is 0.034. So it is under root of 0.011 plus 0.034 divided by 1 into 118.55 raised to 1 by 3 is 4.91 plus 20.1 raised to 1 by 3 is 2.72 and square of this. So DAB is equal to 1 into 10 to the power minus 7 into 18352.79 into summation of this 2 is 0.045. So it is under root of 0.045 divided by 1 into 7.63 square. So that gives us DAB as 6.70 into 10 to the power minus 6 meter square per second. So for aniline and air at STP conditions, the diffusion coefficient of aniline in air, it is 6.70 into 10 to the power minus 6 meter square per second. So with this, we complete calculations for all the gas mixtures that have been mentioned in the numerical statement. So we have got the diffusion coefficient for each of the case. I hope you must have understood. The only thing is, if you are using Fuller's method, you should remember this equation. That's it. So we have used Fuller's method to get diffusion coefficients for different gas mixtures at different conditions of temperature and pressure. So with this, I will end my discussion for this video lecture. I hope you have learned something out of this discussion. If you have any doubts, you please mention them in the comment section. So thanks for watching this video lecture. Do subscribe to my channel. Tell your friends to subscribe to it and hit the bell icon so that you'll be notified as soon as I upload any new video on my YouTube channel. In my next video lecture, I will start my discussion on estimation of diffusion coefficients for liquids. Hope to see you soon in that video. For time being, have a nice day. Bye bye and take care.